everyone. I'm Damayanti Sinhala. Let's start today. Discuss on normal probability distribution. This is an important important lesson uh, because mainly it represents the foundation of statistical inference. So I hope to discuss with you about normal distribution, what is normal distribution, and normal probability density function, uh, and also standard normal distribution, and how we can compute uh, some practical scenarios by using standard normal distribution paper. This is how I am planning today lesson with you to discuss on the same topic, normal probability distribution. So before that, I need to say something about probability distributions as well. So you all are familiar with probability distributions, something like main probability distribution, Bernoulli distribution, binomial distribution, and Poisson distribution, all that. So let's see. So I talked to you about some combinatorial concept with tree diagrams. So can you remember? I gave some instruction you to find solution with the knowledge of probability by using tree diagram. So can you remember that? So this is one example for you to think about that further. So this has, you can see here it is, you can see three uh, order the letters A, B, C. So starting from A, B, C. So we have divided A, B, C as a root of a tree. That means three separate items, so three separate branches. Okay, right. So working with electricity now. So I am going to fixing my board. Right, right. Now you can see this is A, B, C. There are three letters. So again, A has divided into two as B and C. B has divided into two as A and C has divided into two as A, B. So likewise, again, we can think about the case B, and again, I can divide it into C, so one branch, and so that means why I ending with C here is, so starting with A, no, A, B, C. Okay, that is how it becomes A, B, C. So next time, if it is A, C, we have to write here rest of the other character B. So that is how we can see A, C, B. So likewise, you can count the scenarios here. BAC and BCA and CAB and CBA. So what I can say you, ABCE one thing and ACB the other one, and BAC the other one, and BCA the other one, and CAB and CBA, right? Different things. So this is how we can separate some combinatorial concepts with tree diagram. So example here we considered as ABC, three letters. So finally we found that there are, so how many finally we found? One and two here and three here and four, five and six here, no? Right, okay, right. Can you please try out to draw it? If you want to write their respective probabilities, you can write here. Say, let's say 0 point here 0.0012. Again, you can write here 0 point. So we can assume that 0.13 or something like that, 0.146. Likewise, you can write here respective probabilities, and again you can substitute same figure to here. So what I wrote for B, 0.0013. For the C, it's you can appear 0.146. So how we can find ABC? So then that is 0.0012 multiplied by 0.0013 multiplied by 0.146, isn't it? So finally you can find what is the answer here. So likewise you can find same thing here, ACB. So what are the respective probabilities? So that is different thing. But what I want to show you, actually ABC, ACB, BAC are different ones. So can you remember I explain you uh, binomial, combinations and permutations? So likewise you can see ABC, ACB, BAC are different ones, no? Different arrangements. Order is matter. There are six ways here. Okay, right. So before start normal probability distribution, let's see something about previous day we discussed with you about conditional probability, probability of a given b. That means a given b equals so these kind of things, no? Probability of a given b, probability of a given b, how we can find if already b happened. Okay, b has done, pb has done, so already happened. This has already happened. Okay, so if pb already happened, so how we can find a given b? So that this is called a given b. A given b. So we need to find what is the intersection. So p probability of a intersect with b where pb not equal 0. Okay, this is how we can find conditional probabilities. So if it is independent events, so every time p a given b equal pa, pb given a equal pb. Got it? You can write it. Okay, so have you copied down? Conditional probability, same thing. In my previous lecture, I explained about this. And now let's see what is Bayes' theorem is. The Bayes' theorem enables you knowing just a little more than the probability of A given B to find the probability of B given A. So that is actually based on definition of conditional probability and the law of total probability. So those who are interested with Bayes' theorem, so I will write first probability of B given A equal probability of A given B divided by probability of A. So that means already have happened. So the event A is already happened. So and we have the probability. So the second time we can see P intersect with B. So probability of A intersect with B plus probability of A intersect with B bar. So that means can you remember what is B bar and A bar is Anupurake. 1 minus B, 1 minus PB, likewise 1 minus PA. So the probability of A given B, so finally applying the definition of conditional probability throughout, uh, for these three theories, that is PA given B multiplied by PB plus PB given A bar multiplied by PB bar. This is how I can explain Bayes' theorem. So that day I told you the conditional probability will contribute to uh, enhance the probability of some kind of application called Bayes' theorem. So that is found by the Bayes. So this is how we can apply Bayes' theorem and not apply, actually explain in the theory. So this is how the Bayes' theorem uh, is going to express you to when it is com- um, combining with complement and the conditional probabilities. Okay, based on the definition of conditional probability and the law of total probability. So applying the law of total probability to the denominator, uh, this is how we can write that one, and finally applying the definition of conditional probability throughout. So then Bayes' theorem will explain us knowing just a little more than the probability of A given B to find the probability of B given A. Okay, this is how I can explain this. Actually, Bayes' theorem I am not going to test at the examination, but for your knowledge. So you have to understand well what is Bayes' theorem. Okay, right, let's know. So when we talking about Bernoulli normal distribution, so uh, so before that there are several other distributions we have to consider. So at the beginning I told you I am going to plan to discuss with you normal probability distribution and their formula and properties and standard normal distribution and counting problems. So applications. So we'll do before that Bernoulli distribution. So that is we can identify as basic one. When we are talking about distribution, basic is the Bernoulli distribution. Okay, Bernoulli එකෙන් තමයි මේ distributions කියන එක මේ ඇත්තටම start කරේ. තව එකක් තියෙනවා uniform distribution කියලා. I'm not going to show you about that, but Bernoulli is useful one. ඇත්තටම හැම distribution එකක්ම ප්‍රායෝගිකව වැදගත්. ඒවා සඳහා ප්‍රායෝගික අවස්ථාවන් දකින්නට පුළුවන්, we can see. But අපි Bernoulli වලින් පටන් අරගෙන Bernoulli and the Poisson and the Bernoulli and the binomial and the Poisson කියන එක we'll talk. That means we starting from Bernoulli trials. B, here B, not beta. Bernoulli trials. So after that binomial. After that Poisson. Let's talk after that normal distribution. Okay, this is how I am planning here. So random variable, you know what is random variable. So here we consider a random variable, that is x, that is defined to have a Bernoulli distribution if the discrete density function x is given by fx that is starting from 0 to px 1 minus py. So p 1 minus p 1 minus 6 for x 0 1 otherwise. Okay, that means I will write here what is fx. So හැම තිස්සෙම මේ distributions ගැන කතා කරනකොට function of x කියන එක එනවා. X is there. So what is y is if because we consider a random variable x. That's why fx starting from 0 to p x 1 minus p 1 minus 6. Right? So it is a discrete density function. Right? Starting from 0, 1, 2, 3, likewise. Where the parameter p satisfies 0, 0 less than or equal p, 0 greater than or equal p, less than or equal 1 minus p. Okay, 0 greater than or equal p, less than or equal 1 minus p. So 1 minus p, there are two situations, p plus q equal 1. Okay, right. So p equal 1 minus p. So that means p plus 1 minus q equal 1. Isn't it? Terunane? P plus 1. P means getting successes, obtaining successes. Q, getting failures. Obtaining successes, obtaining failures. Okay, right. P equal obtaining successes, Q equal obtaining failures. So P plus Q equal 1, P equal 1 minus Q. So P 1 minus Q equal 1. Anything you want to write? Bernoulli trials representing two situations, getting successes and getting failures. Right, okay, let's go to next. So binomial distribution, in binomial distribution, that is also we consider variable x that is defined to have a binomial distribution. That is also a discrete function. So how we can write it? Fx equal starting from 0 ending with ncx p to the power x 1 minus p 1 minus x here. So fx equal fx, yes, fx equals starting from 0 ending with ncx p to the power x q to the power n minus x or 1 minus p 1 minus x. So x will goes from 0 to n, ending up with n. So here this time where the parameters n and p satisfies, 0 greater than or equal p, that means getting success, less than or equal 1 in ranges over the positive integers, and 1 minus p often denoted by q. Same thing. Same thing like Bernoulli trials, Bernoulli distribution. Right? So, what are the examples? So, කාසයක් උඩ දැමීම වගේ එකක් ගන්න පුළුවන් දෙපැත්තයි තියෙන්නේ. So getting head success, that means half half නෙන්නේ එකේ නේද? සිරස වැටීම, අගේ වැටීම, භාග්‍ය භාගී. If it's a balanced coin. P equal half. P equal half. O 0.5. Q equal minus 1 minus half. O 0.5. අසාර්ථක සිදුවීම. Right, okay. Let's move. You need more time. So remember that the binomial distribution is possible to calculate the probability of success or failure. So we must have the knowledge about what is N, what is P, what is Q. Three things: N, P, Q. And also about knowledge about random variable X. And also when we talking about properties of binomial distribution, so in this case it can be shown that two summary measures depend on the simply on the values of n and p as mean and the variance. There are two. So mean of the binomial distribution equal NP. That means count what are the sample size, what is the sample size, and uh, uh, find what is the probability of getting success. That is how. Say for an example, n equal 10, p equal half. So what is the mean of that distribution? 10 multiplied by half. That is mean here is 5. So how we can find variance? Variance is NPQ. Let's say n equal 10, p equal half, and q equal half. So then we can multiply together these things, 10, half, again half. So can you try out to solve the problem? Here 5. So 5 divided by 2, that is 2.5, no? Variance. So there are two properties in binomial distribution. Write down please. Two properties. One for the mean, the other one for the variance. For mean here is NP, variance here is NPQ. That is for the binomial distribution. That means NP represents the average number of successes in trials. Okay, right. So then, so binomial distribution formula. So I will write here formula for binomial distribution. Equal NCX p to the power x q to the power n minus 6. Okay, please write. Right, okay, let's do some example here. So suppose if you are given one example like this, right here. There are 10 workers in a factory. There are 10 workers in a factory. That means n equal 10. If there are 10 workers in a factory, from that 10, 6 belong to a trade union. Okay, 6 belong to a trade union. That means of that 10 workers, 6 belong to a trade union. That means 6 upon 10. So what is the probability there? 0.5. 6, no? Right? That is P. P equals 0.6. ACM එකපාරටම කිව්වා. 6 belong to a trade union. So you were asked to find what is the probability that if a shift consists of 3 workers, they will all belong to a trade union. Okay, right. So you were asked to find what is the probability that if a shift consists of 3 workers, that means x is 3. X is 3, that is your random variable. Now you are asked to find the probability that if a shift consists of 3 workers, they all belongs to a trade union. So from that 10 people, so 6 are belongs to trade union, that is P equals 6. So if P equals 6, you know that what is Q? 1 minus P, that is 1 minus 0.6. So what is it? 0.4, no? So that means 4, 4 divided by 10. Altogether, 6 plus 4 equal 10. So that's right. So we know that what is Q, right? Since we are in binomial distribution, right? It's okay now. So you were asked to find all these 3 people belong to a trade union. So it is required to find the probability through binomial distribution. So since we have given 2 situations, so that means people are belong to trade union or not, right? So uh, 2 things, no? So that means getting success, that is P equals 0.6, Q equal 0.4. හරිනේ දෙකයිනේ වෙන්න පුළුවන් මොකද්ද කියන්නේ ට්‍රේඩ් යූනියන් එකට වෙළඳ සංගමයකට අයිති වෙන පිරිස ඉන්නේ 10න් 6ක්. එතකොට රැන්ඩම්ලි 3 දෙනෙක් ගත්තාම ඒ 3 දෙනා වෙළඳ සංගමයට අයත් අය වලින් වීමේ සම්භාවිතාවය තමයි අපෙන් ආන්නේ. So that means probability of x කියන එක මෙන්න මේ 3 දෙනා ට්‍රේඩ් යූනියන් එකට අයත් වෙනවා. Right? What is the selected 3 people will all belong to trade union. So I will write here. What is the selected people, selected workers, selected 3 workers. Workers belongs to belong, no S, belong to trade union. Okay, right. So that means Px equal 3. So now you can apply a binomial distribution here in Cx, P to the power x, Q to the power n minus 6. Okay, when Px equal 3, n here is 10, C x here is 3, P here is 0.6 to the power x කියන්නේ 3 and Q here is 0.4. N minus 6 means 10 minus 3. So that means we know that how we can simplify NCR. I have told you NCR equal n factorials r factorials n minus r factorials. Okay, this is the formula, so we have to use here. right? Now n means 10 here, 10 factorials. R means 3 here, 3 factorials. Again n means 10 minus r means 3 factorials multiplied by zero point 0.6 to the power 3. Okay, zero point 0.6 to the power 3, zero point 4 to the power 10 minus 3, 7 ne, 10 තුනක් 7. Now you can find the answer. I'll give you some time to find. So do it quickly. Okay, did you find the answer? So what is it? What is the answer there? කීයද ආවේ උත්තරය? What is the probability? That is actually 0.0425. Check with your answer. 0.0425. Of 10 workers in a factory, 6 belong to a trade union. So then you are asked to find what is the probability that if a shift consists of 3 workers, they will all belong to trade union. So that is actually a binomial distribution application. So then you have to find what are the results that can take by following binomial distribution. And also you can find what is the mean and the variance of that distribution. What is the mean? Let's see. Mean of the distribution. Mean, that is NP, no? NP. So you know what is N here 10, P here 0.6. So you can find what is mean. That is actually 6, no? So the variance NPQ. So N here is 10, P here is 0.6, Q here is 0.4. So find what is the answer there. What is variance? So what is the answer there? 2.4, no? Right. That is 2.4. That means Vichulakave variance. Mean here is 6. Mean here is 6 and the variance here is 2.6. The answer here is 0.0425. So hope that you are okay with what I am explaining here about regarding a binomial distribution. There are two situations we can see: getting success and getting failure. So success probability representing P and failure probability representing Q. And also this is the formula that we are using to find respective probabilities. In our case, that the selected 3 workers from a particular factory. So 3 workers is considered as the random variable. It's equal 3. P here is representing the probability. So probability x equal 3 equal, write the formula first, ncx p to the power x cube n minus x. Okay. Here ncx means ncr. So in factorials, r factorials n minus r factorials. එතකොට අපි දන්නවා r ප්‍රමාණයක් ගන්නවා කියලා කියන්නේ අර random variable එක represent කරන එක. එතකොට මේ so we have to use the uh, NCR formula to simplify NCX. Okay, that is how we simplify the situation. And 0.6 to the power 3, 0.4 to the power 7. Likewise, we can find the answers. Right, okay. So same thing, let's do some other example. Same thing we can use here. Say you are you want to find x no more than 2. X equal no more than 2. What is the meaning of it is, you have to find 10c0 p to the power x q to the power n minus 6 plus 1001, okay, p to the power x q to the power n minus x plus 10c2 p to the power x q to the power n minus x. Likewise, okay. If x no more than 2, දෙදෙනෙකුට වැඩි නොවී මේ සම්භාවිතාව. ට්‍රේඩ් යූනියන් එකට සම්බන්ධ වෙන ප්‍රමාණය randomly ගත්තොත් දෙදෙනෙකුට වඩා වැඩි නොවීමේ සම්භාවිතාවය no more than 2. That means 10c0 10c0, you know how to simplify 10c0. අර විදිහටම ගන්න 10 factorials 0 factorials 10 minus 0 factorials. So you can simplify them. P here is 0.6. X here is first time 0. Q is 0.4. N here is 10. 10 minus 0. Plus 10c1. QP here is 6. 6 to the power 1. 0.0 to the power 9 plus 10c2. P means 0.6. Power here is 2. Q means 0.4. Power here is 10 minus 2. Okay. If you simplify this part, you will get the answer as 0.0001. Okay, plus if you simplify this part, you will get the answer as 0.0016. Plus if you simplify this part, So you will get the answer 0.0106. So finally, the answer will be 0.0123. Got it? Right, that is the answer. So what we did here, we found if there are 10 people belongs to trade union, so we have to find probability of getting X no more than 2. How we can find, first find C0, 10 0, 10 0, and secondly 10 C1, thirdly 10 C2. So find the answers and get the final answer uh, and verify with my answer. So take a few minutes. Here the P equal 6 upon 10, Q equal 4 upon 10, and N equal 10. Same variance and mean. Okay, right. Let's go to next one. Since we have limited time. So this is what we explained so far regarding binomial distribution. So let's move to next situation. So the experiment involves an identical trial and each trial has only two possible outcomes denoted as success or failure. Each trials are independent of previous trials. P and Q remain constant throughout the experiment. Likewise, we can write them. So the next distribution is Poisson distribution. Poisson distribution. That is a random variable C that is defining as have a Poisson distribution if a discrete density function. So random variable X is defining as 0 to E minus lambda, lambda to the power X divided by X factorial. So you know what is factorial. So මම මොකද්ද කරේ මුලින්ම factorials ඉගෙනුවා combinations ඉගෙනුවා permutations ඉගෙනුවා නේද ඒ ඉගෙනුවේ මෙන්න මෙතන. So then binomial Poisson distribution is fx equal formula is e to the power minus lambda, lambda to the power x divided by x factorials. So how we can define x, that is for all x starting from 0, 1, 2, 3, so on up to 10. මේක මතක තියාගත්ත නම් ඇතිය. This is enough. So if we carefully observe about properties of Poisson distribution, we can define the values of the summary measures as mean and the variance. So mean here is actually lambda. That means parameter of the distribution. And also variance equal lambda. මේම ව්‍යාප්තියේ මධ්‍යන්නේ සහ විචලතාවය හෙව්වහම එය පරාමිතියට සමාන වෙනවා. Mean also lambda and the variance also lambda. Right? Further, for the Poisson distribution formula, please remember px equal e to the power minus lambda, lambda to the power x divided by x factorial, where px equal the probability of x occurrences. In an interval of time or space. Time or space. Lambda is the average number. Or expected value. And expected value of x, average number of occurrences of x. And E here is mathematical constant that is equal 2.7183. It's a mathematical constant. Right? Here the mean equal lambda, variance equal lambda. Please write. Okay, right. Let's let's do an example. So the average number of errors on a page of a book is 1.4. What is the probability that a page will contain 4 errors? Okay, the average, shall I write it? Example. That I will write here. The average number of errors on a page of a book is 1.4. What is the probability that a page will contain 4 errors? Okay, the average number of errors on a page of a book is 1.4, right? That is 1.4. Lambda equal 1.4. That is the average number of errors. That is parameter. That is 1.4. That is the average. So here the x equal 4. That is random error. So how we can find if x equal 4, that is e to the power lambda minus lambda, lambda to the power x divided by x factorial. So we can write here 2 point. So what is the figure there? 2.7183 to the power minus 1.4, again 1.4, and x here is 4 divided by 4 factorials. Right, I don't have a scientific calculator to find these things, so please find the answer and understand what is the situation here. Okay, 4 factorials. බලන්න සයින්ටිෆික් කැල්කියුලේටර් එකකට අරගෙන E කියලා කියන්නේ 2.71 ඍණ 1.4. right? ආපහු ලැම්ඩා කියලා කියන්නේ ඔයාලගේ පැරාමීටර් එකනේ මෙතන. එතකොට 1.4 වල 4 to the power. හතරේ බලය divided by 4 factorials. answer එක හොයා ගන්න. That is the average number of errors on a page. So containing 4 errors. Okay? The probability that a page will contain 4 errors. Sorry, the average number of errors on a page of a book is 1.4. So we found what is the probability that a page will contain 4 errors. Such kind of problems actually in this type of situations, that is Poisson distribution. මේ වගේ ඒවා එන්නේ Poisson distribution එකට. ඔය පොතක පිටු ගානක තියෙන දෝෂ, ටෙලිෆෝන් operator කෙනෙකුට එන calls, number of calls වගේම, right. Clear? So I'll give you 2 minutes. So what is the mean of this situation? Mean equal 1 minus 4 and the variance also 1 minus 4 equal to the lambda, no? Find the answer here. What is it? And mean here is 1.4, variance here is 1.4. So look at the hoya. E is a mathematical constant. That is 1.783. Okay, right. Poisson distribution, this discrete probability distribution, one of the discrete probability distribution, where the random variable is the number of errors, number of events in a given interval. So there are several examples I can show you. Number of customers who arrive at a checkout counter of a grocery store in 1 hour or per hour, and number of industrial accidents per month at a manufacturing plant, and one other number of bankruptcies that are failed in a month. Likewise, we can see some examples, the number of errors in a book, a number of phone calls coming to a telephone operator, likewise. So that is countable infinite distribution. Poisson distribution is a countable infinite distribution. So Poisson distribution is a discrete probability distribution where the random variable is the number of events in a given interval. Okay. Anything you want to write, you can copy down now. Countable infinite distribution. Poisson distribution. Please write the examples. අපි කරපු එකත් හරි තව examples ටිකක් ඔයාලට හිතලා ලියන්නත් පුළුවන්. Okay? You have to work, find the answers, understand the situations, what are the places we can apply Poisson distribution, and try to give examples. Right, okay. And Poisson distribution, the probability an event occurs in any interval is the same for all intervals of the same size. So further you can understand the number of occurrences of the event in one overlapping interval is independent of the other. So the probability that two or more occurrences of the event in an interval approaches zero as the interval becomes smaller. Right? Right. We look at three distributions about three distributions. Actually, we gave up attention on Bernoulli trials and binomial distribution. After that, we move to Poisson distribution. Let's see now if we have number of items or sample size or number of cases or something. So here you can see as n increases, the binomial distribution approaches to a bell-shaped curve. So here you can see n equal 6, here you can see n equal 10, here you can see n equal 14. Okay. So then starting from here, so first case you can see it is in a binomial distribution. Again it is increasing. So finally what we can see, that becomes a normal distribution. So in a normal distribution, the parameter here is mean mu. See how I am writing it? Mu. Here mu equal mean equal 0. Variance equals sigma squared, that is variance, that is 1. So it is a bell-shaped curve. It is a bell-shaped curve. So mean here is 0. Right? Then, so I will show you probability density function here. So see here, normal probability density function, fx equal 1 divided by 2 pi sigma squared e to the power minus x minus mu squared divided by 2 sigma squared for starting from minus infinity to x plus infinity. So there are some mathematical constants also here. That is e equal 2.718 and pi equal 3.141592965. Okay, right. You can apply these equations. Uh, to the cases that is practically in some kind of දැන් උසෙහි ව්‍යාප්තිය බරෙහි ව්‍යාප්තිය ලකුණු වල ව්‍යාප්තිය ඔන්නෝවා ප්‍රමත ව්‍යාප්තික තියෙනවා කියලා දැන් you know that දැන් උසස් පෙළ විභාගයේ ප්‍රතිඵල Z score එකෙන් නිගන්නේ නේ. ඉතින් ඔන්න Z score එක ගැන තමයි අපි මේ කතා කරන්නේ. Z score එන්නේ කොහොමද කියන එක. So first we will have to learn about natural normal probability distribution. This is how it is showing. So it is actually that means random variable starting from minus infinity to plus infinity. ඍණ අනන්තයේ ඉඳලා ධන අනන්තය දක්වා යනවා. But not touching the end points. මෙන්න මේවා මේ bell shape එකේ බලන්නකො මේවා එකට එකතු වෙලා නැහැනේ. මෙහි මේ පැත්තට යනවා. මේ පැත්තෙන් මෙහෙට යනවා. ඒක තමයි අනන්තයට යනවා. ධන අනන්තය සහ ඍණ අනන්තයට යනවා. This is how we can define the normal probability density function. In Sinhala meaning, this is called Pramata Vyaptiye Sambhavita Ganatva Stritaya. Density means Ganatva. Please copy down. Okay, right. You can remember these things, no? As increases the binomial distribution approaches to a bell-shaped curve. The normal distribution formula you have right now, that is actually produce a smooth bell-shaped curve as shown in these figures. So the precision, location, and shape of these curve depends only on the value of the two parameters mu and sigma. So it will be seen that the curve is unimodal and symmetrical around the mean. So one other thing, the tails of the curve are asymptotic to the horizontal axis. Okay, shall I write them in my board? Right, talking about normal distribution. Normal probability distribution. Pramata Sambhavita Vyaptiya. You know what is formula? Right, probability density function you have to write. So that is fx equal 1 divided by 2 pi sigma squared within brackets and within the root, and right here again mathematical constant e and minus 2x minus mu අනිත් විදිහට ලියුවත් කමක් නැහැ කලින් තිබිච්ච විදිහට both are correct and the x squared. Here the fx, what is fx? That is probability density function PDF, and mu is the mean, so mean equal mu, and sigma is the variance, sigma is the standard deviation, mu here, mu standard deviation, pi is a mathematical constant, that is 22 divided by 7, that is 3.1416 equal 2.7183. These are the things you need to get clarified when we are talking about normal distribution formula, that is PDF. So that is a bell-shaped curve. The other one is the curve is unimodal. Curve is unimodal and symmetrical around the mean. The tails of the curve are asymptotic to the horizontal axis. Asymptotic. To the horizontal axis. They never touch the horizontal. So in theory, X can assume infinitely large positive values, infinitely large positive values. Or infinitely large negative values. Negative values. Please write down. Can you read my handwriting? The curve is unimodal. Unimodal. මාත එකයි. Why is that? ඇයි එහෙම කියන්නේ? මාත එකයි කියලා කියන්නේ මොකක්ද? ඒක තේරෙනව නේද ඔයගොල්ලෝ? Unimodal කියන එක දන්නව නේද? මේ මාතේ මධ්‍යස්ථය ඔක්කොම මෙතන තියෙන්නේ. Right? Mean, median, mode all are here. So no bimodal one ඔන්නෝම එන්නේ. මේ මගේ දෙකක් නැහැනේ මේකනේ. So this is called unimodal. මේ peak වෙච්ච තැන් එකයි තියෙන්නේ මේකේ. That is called unimodal. Symmetrical around the mean. මේ මධ්‍යන්නේ වටා තමයි මේක symmetric වෙන්නේ. Here 0.5, here 0.5. So මේ දුර එකයි. The tails of the curve are asymptotic to the horizontal axis. Right? This is x-axis. Never touches the horizontal and infinity large positive values, so large negative values. This is how we interpret it. Right? Okay, let's see now. Hope you have copied down. Copied it. Okay, well, let's right, this is the one. So what are the properties of normal distribution? It is a bell shape and symmetric distribution. Because of the distribution is symmetric, one half 50% presenting 50% and the other half 50%. That means 0.5 each. Each is characterized as a different pair of mean, right? And asymptotic to the horizontal axis. The area under any normal probability density function with k sigma means the same for normal distribution regardless of the mean and the variance. So no need to write these things, but listen. If several independent random variables are normally distributed, then their sum will be normally distributed, and also the other property is the mean of the sum will be the sum of all the individual means, and the variance of the sum will be sum of all the individual variance. So by virtue of the independence, ඒවා ලක්ෂණ විදිහට කියන්න පුළුවන් properties විදිහට if several independent random variables are normally distributed, then their sum will be also normally distributed likewise. So this is what I told you. If there are x1, x2, xn, they are independent normal random variables, and their sum of the s will be also normally distributed with expected value of space, sample space, and each and every scenarios. That means expected value of x1, expected value of x2, expected value of xn likewise. Variance සැලකුවත් එහෙමයි. මධ්‍යයන් සැලකුවත් එහෙමයි. Vx means variance. Variances ගත්තත් එක් අවස්ථාවේ අර ඉන්ඩිපෙන්ඩන්ට් වෙන වෙලාවල්වලදී එක වෙන වෙනම අපිට ගන්න පුළුවන් variances එකතු කරන්න. They are properties. If x1, x2 are independent normal random variable, ඒ වෙලාවේ අපිට ඒ විදිහට පෙන්නන්න පුළුවන් no need to get everything. ඉවච්චර ටිකක් ගැඹුරුයි. But Finding probabilities of the standard normal distribution. Now ඒක උගක් වැදගත්. අපි ඒක තමයි ඔයගොල්ලන්ට applications කරන්නේ. Hope to give some example next time, but this time I will explain. There are normal distribution tables. Normal distribution tables තියෙනවා. ඒ tables අපි normal distribution කියලා කිව්වට we have to get it as standardized formulas. Okay, standardized formulas වලට හරවලා we have to compare with computing value එකත් එක්ක සංසන්දනය කරන්න පුළුවන් වෙන විදියට සම්මත වගු පිළිතලා තියෙනවා. සම්මත ප්‍රමත වගු. මේ තියෙන්නේ one part of it. That is called standard normal distribution table. Standard normal distribution table. This next time මම මේක පැහැදිලි කරන්නම්. Okay, මේ එක කොටසක් මේ තියෙන්නේ. So you can see 0.07. That is 2.4 වල මෙන්න මේ this one. 2.7 කියලා එක දෙන්නේ කොහමද? 2.40 වලට 0.07 එක තමයි මේ හැදෙන්නේ. So how we can refer it from the respective table? So 0.07 is here, 2.4 is here. So this is the place. This is the place. What is the probability there? 0.4934. Ek shaded area you can see here. So this is the place. You can copy down. ඒක ඇඳ ගත්තට කමක් නැහැ. Okay, right. So this is the table. You can see. It's a table. Set variable එක how to get x minus mu divided by sigma. ඔය විදිහට තමයි standardize කරගන්නේ. So I will let you know next time. So this is the table. You can see here. X values are here 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, likewise. So then the other figures are here 0.00, 0.01, 0.02, 0.03. So see all the others here. one part here එක කොටසයි මේක තියෙන්නේ එතකොට so some other shaded area 0.04 that is 3.0.3997 තියෙන්නේ 1.28 මෙතන ඒ විදිහට මේවා අඳින්න ලියන්න බෑ වගුවක් දෙන්න ඕනේ වගුවක් හොයාගන්න find the table so I will try to put, do the LMS one table for you to refer and to see okay right these are the things I want to talk to you today so hope you could understand what I explained here starting from previous lesson difficulties that means conditional probability and all that ඒවා පැහැදිලි කරා then after that time out to probability distributions and started to explain Bernoulli trials Bernoulli distribution then after that binomial distribution then after that time out to Poisson distribution then finally discuss about normal probability distribution but not fully explain normal probability distribution we need to get understanding more about that and also some practical situations how we can compute the probability by looking at that standard normal distribution tables so next time we'll try to understand them so most important is final one normal probability distribution so that is very important and also අනිත් එකත් පාසුවට ගන්න එපා binomial distribution එකේ we solve some problems and also Poisson distribution එකේ we did some problems and practical things so with at the examination I'm not going to check Bernoulli trials but there may be some questions on binomial distribution and Poisson distribution questions but in today's discussion I did not touch any practical situations on normal distribution but I explained normal probability density function but remember that when we are explaining normal probability density function you have to write what is it what are the speciality of normal probability density function and what are the characteristics special things so it is a bell-shaped curve and about mean and the variance and the minus infinite and plus infinite so all that you have to understand before going to the counting problems okay and what are the other things and I talk about normal probability distribution table and these kind of things today we discuss and we'll see next time what we can do with as the problem solving part by using a normal probability distribution table. That is actually standard normal distribution table. Normal distribution එක standard normal එකට convert කරනවා. We can convert normal distribution to the standard normal distribution. Mathematicians, statisticians using such kind of things. So otherwise we can't do any computations. Okay. So let's see next time how we can do it. Okay, thank you very much for listening. Have a nice day.